Hello and welcome to a parental support math session brought to you by the Kemnall Academy Trust. My name is Rhiannon Balfour and I'm a lead practitioner. Today I'm going to lead you through some strategies and background information about subtraction in Year 1 so that you have the confidence to support your child as they move through primary school. When subtracting from a one-digit number, real objects should be used so that children are physically able to take them away in order to find out how many are left. In the first picture, you can see the calculation 7 subtract 3 is equal to 4. There are 7 blocks in total, so we would say the whole is 7. 3 blocks have a circle drawn around them with an arrow. It is at this point that children would actually take them away and move them to one side. They would then count the blocks that are left to find the answer. In this case, 3 blocks will have been taken away and there are 4 left. So 7 subtract 3 is equal to 4. The below image demonstrates how to take a one-digit number from a two-digit number. When children are subtracting a one-digit number from a two-digit number, the children will need to make the whole with tens, and ones, again, physically, take away the ones to see what is left. Moving on from the concrete stage, the children will be able to represent the objects pictorially and, as in the middle image here, cross off the amount they are subtracting. 15 subtract 3 is equal to 12. Finally, this will become a mental image for the children, which means they will be able to visualize the total number of cubes or pictures and mentally solve the equation. When counting back, children count back in ones until they've subtracted the correct amount. In the example above, 6 subtract 2 is equal to 4, children can use a number line or a ruler to place their finger on 6, as this is the number they are counting back from. The calculation is asking them to subtract 2, so children will then count and make 2 jumps of 1 backwards, placing their finger on 5 and then 4, which is how many are left when you subtract 2 from 6. This could then lead on to children showing their thinking by drawing out the numbers on the number line. Finally, children will be able to do this speedily, visualising numbers on the number line or quickly glancing down at their fingers. Pupils should be encouraged to rely on number bonds as time goes on, rather than using counting back as their main strategy. Addition and subtraction are taught alongside each other. The part-part-whole model is the concept of how numbers can be split into parts. Children using this model will see the relationship between the whole number and the component parts. This helps learners make the connections between addition and subtraction. They are the inverse of each other. Inverse is the opposite. Addition is the opposite of subtraction, and vice versa. When using a part-part-whole model to solve subtraction, children will start by using concrete objects and placing them in the model. In the example, the child is solving 10 subtract 6. 10 is the whole, and to begin with, there were 10 cubes in the whole where 10 is written. The child has then taken away 6 cubes and moved 6 into one of the parts, leaving one part empty. There are 4 cubes remaining, so 10 subtract 6 is equal to 4. Those cubes should then be moved into the other part, which will reinforce the relationship between addition and subtraction, as you can now clearly see that 6 plus 4 is equal to 10 and 4 plus 6 is equal to 10, as well as 10 subtract 6 is equal to 4 and 10 subtract 4 is equal to 6. Children can then move on to drawing objects to represent the concrete. In this example, there are 4 tables to solve 4 subtract 1. 4 will move into the whole section of the model. 1 table has been crossed out to represent being taken away. 1 can be written in one of the parts. This leaves us with 3 tables left, so 4 subtract 1 is equal to 3. Children will recognise and understand the calculation they need to solve to complete a part-part-whole model. In the abstract example, 10 is written as the whole and 6 is one of the parts. As the whole is given, children know they need to subtract 6 from 10 to work out the missing part. Before we delve into the Make 10 strategy, it is important to understand the use of number bonds to 10. In Year 1, children should be beginning to quickly recall pairs of numbers that total 10. 10 fingers, cars, Lego bricks, or questions such as, we have 7 apples, how many more do we need to make 10, are all good ways and resources of reinforcing this learning. The Make 10 strategy supports children when subtracting a 1-digit number from a 2-digit number. Pupils need to identify how many need to be taken away to make 10 first, partitioning the number being subtracted. Then they take away the rest to reach the answer. The first example here shows how the Make 10 strategy is used to calculate 14 take away 5. The children start by placing 14 cubes into the grids, making one complete grid of 10 and 4 left over in the second grid. The next step is to subtract 5, but we will start by subtracting 4 to reach 10. This means we have partitioned 5 into 4 and 1. We now have one more cube to take away, leaving us with 9. So 14 subtract 5 is equal to 9. Once children are confident with using objects to make 10, they can move on to using a number line to show making 10. In this example, they are solving 13 take away 7. They start by partitioning the 7 into 3 and 4. Taking away first makes 10, then there are 4 left to subtract. So you are left with 6. So 13 subtract 7 is equal to 6. As we said earlier, once children are confident with their number bonds to 10, they'll be using this strategy mentally, knowing that to solve 17 subtract 9, they firstly subtract 7 to make 10, leaving 2 left to subtract, which will equal 8. Thank you so much for watching this session. We hope that you will find it helpful when supporting your child with mathematics at home.